Now today we're going to continue with another section of logarithmic rule, where we're going to learn how to express the power of an index. That if an index has an extra power, how do you simplify it? So let's take from the simplest form. You all know that a raised to power is 0 is equal to 1, and as well you all know that as a raised to power 1 is equal to a. So come on, this is the indical form. So what's going to be the logarithm form of this number? So the logarithm form of this number is going to be the log of the number. So what's our number here? 1. To what? To what base? To base a gives us what we have here is 0. And here we have the log of this number. So what's the number? My number is at this side. So I have, so the log of a base of its exponent will give us what we have here, 1. So this rule is very important, meaning log of 1 to any base is equal to 1, and log of a number similar to its base or same as the base is equal to 1. So if this is clear, come on, let's use this to get some other things apart from this. Now check. If I have a number, like I told you, m is a number which is equal to a raised to the power of x. So m is a number raised to the power of x. If this number is also, I repeat, is also expressed in an exponent form or in an index form, what did I mean by that? Meaning, let's try to express this by changing it to this. That is m to a power of y can easily be expressed as, what is the index of m? A raised to power x. So this become a raised to power x or raised to power, what do we have here? Y. I think this is very clear. M is equal to raised to power x. This is also similar to what we have here, m raised to power y. And what is the index of y? What is the index of m? So the index of m is expressed as what? It's expressed as this. So your y can cancel y, and I get the same thing. So this basically means that this implies to this. Now let's go. Now can we apply our logarithm form? So what's going to be the log of this number? So I'm going to have log of what? M to a power of y. But what is our base? So here we're going to be having a base of this to be a, let with what we have a x and y, xy. You know, I told you in indices, this is the base. The base of this exponent is a, and what is the power or the exponent is xy. How do I get that? When you open the bracket, you multiply. So therefore, it's going to be the log of this. So the log of m raised to power y to its base give us what we have here, the power xy. And do not forget, what is our x? Our x ordinary from here is equals log of m base, what do we have here? Base a, that is x. You know, we still have y, so many times y. So our y is going to be here. So times y. So there is this. So what are this basically? This rule shows. This will let us to know that whenever a log has a power, yeah, so you can easily take it to the back of the log, and likewise you can take it, you can take it to the back of the log, and that become what? Y log m base a. Or you should make the coefficient of the log to be 1. Yeah, making the coefficient of the log to be 1, meaning, let me make sure that I don't have any number here. So if I don't have any number here, so I'm going to treat it. I'm going to take the number here. It's going to be the power of this log of a number, which is m. So thank you. We'll continue in our next class.